Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in our deep programming language series. Today, we're going to continue thinking functionally, or rather just doing something that's very common, and we're going to talk about filter. Now, if you haven't seen the previous episode, go ahead and make sure you watch that, because we talk about map and filter tend to work very nicely together. And of course, we'll get into reduce, so make sure you subscribe for that. But with that said, let's go ahead and jump into the deep programming language website here. We'll go to the library reference, and we're going to go down to standard algorithm, and we're going to go ahead and talk about filter. So again, you're going to find filter under the iteration section because again, we're going to basically be looking at every element and filtering or only keeping the elements in our range that we're looking at that we care about. So let's go ahead and take a look here. So again, the basic idea is we'll have some predicate here. So again, this will be some sort of templated function, and we'll only return a range that satisfies whatever this predicate function is. So let's go ahead and take a look at some of the examples, and we'll go ahead and dive in here. And actually, we'll just go ahead and play around with this, again, making sure that we add in the algorithm library here. And let's go ahead and create some array here just to give us some values here. 1, 2, 3, 4, 5 is fine. And yes, there is iota. We'll get into that later for those who know about that. But let's just go ahead and create that manually. 1, 2, 3, 4, 5 for our array. And again, the point is here, we could have a for each loop where we look through everything and then have some result here that we build up. So for instance, we could look at each element in our array, and we could go ahead and have some sort of function here where we just accumulate things. I'm just going to call this empty array for now. And we would write something like, if the element is greater than 3, then we append it to this array. And then we could write out the empty, empty array is actually a bad name for that. Let's just substitute that for, let's go ahead and do a substitution here. Empty array. Always good to think about what our names are to, how about result? There we go. And let's go ahead and run this here. So of course, 4 and 5 are our result here. So, I mean, immediately you can see this kind of gets a little bit messy versus the one-liner we could do, where I'm just going to, instead, let's go ahead and just comment this out here. We'll go ahead and just say our result. Actually, let's just go ahead and do the right line first. Array, filter, and again, what's our predicate here? A greater than 3. And we'll go ahead and give that a run here. And you see that we have the same result here. So it's really nice to be able to clean up our code in this way and just call the filter function for exactly what we want to do here. Now, of course, we can pass in other functions. Now, these need to be predicate functions, so something that evaluates to true or false here. So let's just call this greater than 3. It'll take in some value here and return a greater than 3. So let's go ahead and we'll repeat this here. But instead, we'll pass in our predicate function greater than 3. And you'll see the exact same result here. And again, you could also have some lambda function here. Let's go ahead and do that as well. For our filter, we're just going to say a greater than 3 as follows. Oops, and I do need a semicolon. Oops, I do need a end my parentheses, but you'll see that we get the same result here for our filter. Okay, so a few different ways that we could work with things here. Now, filter also becomes quite useful when we start chaining together results. We haven't looked at chain, but let's say I've got multiple arrays. I can chain them together. Let's actually just do that here. I don't know if we'll have a separate video for it, but I think it'll be useful. Let's just go ahead and chain together 2 arrays here, meaning I'm going to create these 2 arrays here. And what we're going to go ahead and do is call on them chain, or rather the function chain array and array 2. And let's make that a little bit bigger here for you. And we'll go ahead and give this a run here. And it says, okay, what is chain? And the idea of chain is it's going to put together 2 ranges for us. So we do need the ranges library here. Let's go ahead and import standard range. There we go. That should get rid of the compilation error. And then you can see that we basically put together array, array 2, and filtered out all the elements that were greater than 3. So let's put together 1, 2, 3, 4, 5, followed by 1, 2, 3, 4, 5, and then filtered out the elements here. Okay, and it preserved their orders here. Okay, so that's something that's nice that we've done here. So just to go ahead and do a little bit of a recap of what we did in the previous video as well, it's worth seeing what the type is when we filter these things out here. Okay, so we could go ahead and see that we get a filter result here, which again, it's giving us some sort of range here. Okay, so if we want to actually save this, for instance, and we did this in the previous video with map here. So if I take our filter, again, I'm just doing a greater than 3, kind of arbitrary. And if I want to save this result here, let's just call it result 2 or whatever. Now, if I run this here, it is going to give me this range here. But again, if I'm looking at this and I see, oh yeah, these are integers here. So again, if I assign the type here to say int here, it is going to panic and say, cannot implicitly convert this expression filter array to, well, basically an dynamic array of integers here. So we need to convert it explicitly to an array, and we'll need to add in our import for standard array. Okay, so not too bad here. And now we can actually do this. Let's go ahead and just hide the type here. And I'll just go ahead and write out result 2. And let's just go ahead and label this just so it's clear from all of our other stuff that we have here. That we have result 2, which is 4 and 5 here. Okay, so that was the idea here. And again, if you want to do more interesting things, again, maybe you're processing a bunch of data here, you chain them together. Just so you can see in one line here, 2 ranges, filter them, convert them to an array so you can save the result, and then you can work with that result too for further processing. Okay, so that's the basic idea here. Okay, so now you see that we have our result here. Now, also of interest here, if I go to the documentation webpage, is to see that there is another type of filter here for getting a bidirectional range here. So you'll notice that it's a little bit different here versus regular filter here. Let's go ahead and just change one of these here and print out the type here and see what the difference is. Oh, let's go ahead and I'll go ahead and just write out. Yeah, let's go ahead and I'll paste that in here. And let's see if this does the trick here. Filter bidirectional. And let's see here. All right. So let's see if there's a difference between these two. Oops. Filter bidirectional. All right. And you will see that we are getting a different result here. So immediately you can tell that there's something different going on here. We get the filter bidirectional result here and filter result. Well, bidirectional is sort of like giving you a range where you can look at both the front and the back effectively. So there is a cost to computing this. You can look at the documentation. In fact, let's just go ahead and look at it here. It tells you, let's see, let's scroll up here, that there's a little bit of a speed disadvantage because we got to find the last element in the range that satisfies the filtering condition, but we get a bidirectional range here. And the advantage or the purpose, as mentioned here, is that the range that we're returning can be spanned from both directions, meaning we can look forward or back. There's actually another function here, retro, which is effectively doing the for each reverse, which we've looked at previously in this series. And again, if you just needed a range to be reversed, you could, for instance, do that. But otherwise, the bidirectional range allows you to get the last element again, which is probably the use case here. Okay, so that's the advantage here. They're both effectively doing the same thing though, as far as supplying a predicate and then again reversing that range, or excuse me, returning that range. Filter bidirectional lets you do things like accessless retro to flip things around. Most of the time I've personally just used filter, but again, it could occasionally be useful to have this filter bidirectional as well. So now you know that it exists. All right. Alrighty, so with that said, let's go ahead and just do a quick code review here of what we have learned here. Let's go ahead back here, oops, to the top. So again, we brought in our algorithm library here. We created some data here. We were motivated a little bit for filter because again, like map, it allows us to relatively easily save our result. It's very concise, very clean in the functional mind here, just like when map, when we looked at it. A few different ways to create it. Or rather run our filter. We can chain things together, which is kind of nice. And then, of course, save our results as we have done previously. And we could do that with a bidirectional range or a filter, a regular range if we wanted. Alrighty, folks. So with that said, I'll go ahead and leave that for you there. If you're following along on my website on course.mshaw.io, you can go ahead and see map, filter, reduce, and whatever else is upcoming here. And thank you, as always, for your time and attention. Hope you're enjoying the deprogramming language series, and I'll look forward to seeing you in the next video.